Alright, what's up Moogfest? Circuit Bending Challenge 2014. This is Stevie B, aka the Circuit Surgeon, right here in Asheville, North Carolina, to present the Cataritone. So what I got here is a marriage between a Casio MT-220, an Atari 2600 game system, and then some external circuitry, all of which is meshed together through a patch bay and a momentary keyboard controller that goes to the Atari. So a couple things about this. Both of these units, the Atari and the Casio, I got for pretty much next to nothing. Neither of them worked when I picked them up. Had some cracked solder joints on the Casio. Had all kinds of faulty components and corroded contacts, and just everything about this Atari was really messed up. They've got really good documentation online though, full service manual, so it was pretty straightforward enough to get that all sorted. Everything over here, let's see, I'll just start going down the line. We got a voltage controlled low pass filter, 2 voltage controlled oscillators, and 2 low frequency oscillators, which are switchable between a square wave and triangle wave. Got the rate indication LEDs on the LFOs. Everything here, and here, like all 3 units function independent of one another. So for example, you turn on the Casio, it's a normal Casio. Turn on the Atari, and the colors are a little bit weird, but it's an Atari, works like normal. And then over here with this stuff that I've added in, I've got a mixer down here, control voltage inputs, oscillator outputs, some CV inputs for the Atari, and then pretty much, let's see, the top 7 connections right here all go to this controller, and pretty much everything else is just some interesting nodes through the Casio and the Atari that I brought out to the patch bay. But I'll give you a little taste of some of the oscillators. So here's one of the VCOs, and we can patch in a control voltage from one of the LFOs. So yeah, I mean, really like fun little unit in and of itself. This thing was put together for all of about, I don't know, $5-6. Super cheap to build. I guess with the pots and switches, probably closer to like 10. Show a parts list and schematics and everything at the end of this video. What else? Okay, so it, as per the competition regulations, it does run on 9 volts. It is battery operated. It's been tested with 6 D-cell batteries, which actually sit right here beneath the little controller. I don't have the pack in it right now. I left it before I came over here to shoot this video. So we're using DC power from a wall wart right now, 9 volts. Show you the battery pack later on when I go through all the parts and everything. So yeah, I guess we're gonna cut and I'll show you some of the sounds and pictures that this thing can make. with some noisy circuits around the low pass filter. It's a high gain circuit, and so it really needs to probably be better shielded than I have it. But I'll just give you a taste of what that sounds like. Hopefully I can get it cleaned up and get it sounding a lot better sometime in the near future. But anyways, as is, here we go. I'm going to plug this external speaker into the audio out and just use a LFO to modulate the cutoff frequency. So here we go with the circuit construction. First off, we got the voltage controlled low pass filter centered around a LM741 op amp. We got a 1 mega ohm potentiometer for controlling the cutoff frequency, 500K pot for controlling the circuit's resonance. I've mounted it here on pad per hole circuit board, just what I had lying around. That 470K resistor, you're going to want to wire to the outer leads of this 500K pot as shown on the circuit. Alright, next we got the LFO. You're going to make two of these. They're both off the 4106 IC. Pretty simple. Got VCO, 1 mega ohm pot for controlling the frequency. You got a CV input with an MPF 102 transistor. Here's the outside view of that circuit. Mine's a little bit messy because I used the strip board. I don't recommend it. I hate working with it. Use pad per hole or use tripad if you got it. This is the LED for monitoring the rate of the LFOs. Alright, here's the audio mixer. TL072 op amp. Pretty much use whatever you got. Anything that works with audio, do good. Here's the outside view of it. We got 5 inputs here. One's hardwired to the Atari. 4 of them are wired to the patch bay. Here's everything mounted into a little box. Here's a shot of the RCA patch cables that I made. Got some crimp connectors for a 9-pin DIN socket that I had to replace on the Atari. This is a shot of the 2N3904 transistors that are mounted on this chip here. Got some really cool effects with that. You're going to want to wire up a wire to the patch bay from this guy. Wire one from this guy, this TC74 HCO4P. Yeah, put another wire here, why not? All these guys are going to be going out to the patch bay. This guy too, you know, if you got a Casio MT-220, just find all these spots, hook up a wire to them, run them to the patch bay. It's going to sound cool. Alright, so you're going to run a couple more wires to a couple pins on this IC. These guys will give you some really cool drum loops and some feedback loop stuff. You get some nice like infinity bends going on. One more spot on this side of the board to bring out to the front. And then here's a shot of everything all together. Flip it over. Got a few more spots of interest. Sorry. Got a few pins running into the main processor on this Casio. Gonna run these 5 guys out to the patch bay too. Got another shot, an overview of this side of the board and everything going on it. Alright, next up we got two 10 ohm resistors running between the main outs and the speakers on the Casio. Ignore the kludge there. We got one more spot of interest, bringing it out to the front. Here's a shot of the whole thing. Alright, so here we go with the actual case construction. Gonna mount up everything, get it all nice and flush, looking pretty. Here's the back side, mounted the top side of the Casio chassis to the inside of this cherry wood frame I made. Had to cut the Atari in half to get it to fit, but that's okay because it's full of a bunch of wasted space anyways. Got everything fitting nice and snug, just enough room left over for that battery pack in the center there. Here's a shot of the patch bay on the back side. Here's a shot of the power lines running to the main power input from the Casio. Everything on a common power rail. Here's the 2.2 kilo ohm resistor running from the mixer to the power amp on the Casio. Another shot of the patch bay. Again, it doesn't matter how you wire that thing up. Here's the CV circuit for the chrominance on the Atari. You're going to wire that up to either lead of the chrominance trim pot on the Atari. A couple more spots of interest for some interesting video bends on the Atari. You're going to want to bring all four of these guys out to the surface. What else? Yes, another shot of that. Alright. Alright, here's the shielding going to the controls for the low pass filter. I had to shield and ground those in order to cut out some of the noise. I'm still working on sorting that out. So here's the finished product. There's the back side. Here's the front side. I hope you guys enjoyed the video. Happy bending. Up next, the bill of materials. Alright, so here's my bill of materials. This is everything except for the Casio and the Atari accessories. The Atari accessories came from the Game Escape here in Asheville. The Casio came from my friend Table Beast. But yeah, this is everything pretty much you'll need to build it other than the toys themselves. If anybody wants a copy of this bill of materials, just leave a comment or send me an email and I can email you the shopping cart and the project directly. So yeah, hope you guys enjoyed. Thanks for watching.